Color is one of the most important and significant factors in the appeal and marketability of a textile and the products that are made with it. So, consider the array of colors that you see when you walk into a store. It's intentional. Each season has a palette with a wide range of colors available to appeal to the largest consumer taste. Determining those colors and how they're applied and what dyes and colorants are used is challenging. And that's what we're going to talk about in this chapter. We're just going to talk about the characteristics of color. We're going to focus on identification. We're going to focus on process. We're going to focus on sustainability. And then we're going to end with problem solving. So what kind of problems happen because of color? So first, we're going to start with color theory. Color theory is a complex phenomenon that combines some science, right? It combines the physics of light, the chemistry of colored objects, the biology of your eye, and then some behavioral science in terms of, social or cultural meaning of some colors. And then, of course, the aesthetics. And the aesthetics is just the appreciation of what we see. And these elements interact to determine, what is seen and, more importantly, how it's perceived. So understanding these interactions help us understand why color is hard to perceive in different light, and why color matching can be a problem, and why some colors are used in certain settings. The color that we see depends on a couple things. It depends on the light source, it depends on the colorant used, and we'll talk about colorants later, and it depends on the human eye. And during the course of the day, we see products, textiles, under different light sources. So we see them in natural light, we see them in fluorescent, we see them in LED, and those conditions determine how we see the color. So ideally, colors that are matched or made in one set of conditions should match in another set. So we should be able to see them as the same color under different conditions. But that's not always the case. And let's add on to folks that have color vision or color blindness that may limit our perceptions. So as you may know, light is a form of energy. Light is just, wavelengths that are visible to the human eye. And light sources vary in the quality and type of wavelength and the type of light that's emitted. And, there is a range of wavelengths, but no single light source is strong across all ranges. And then there's artificial light. And, artificial light, depending on its source, could be either weaker or stronger in a yellow region or in a red region. So there is a spectrum of several common light sources. And that's the gauge the chart that you have here on the screen. So what this means is that two textile products that look as if they're the same color at home may look quite different in a retail setting or in a parking lot or just depending on the light source. And there are two terms that we're going to learn that determines how a color looks based on its light source. So the first term that you need to know in terms of color theory is Metamerism. And that just means that two colors match under one light source, but they don't match under another. So think about it. You got something and you got home, you're like, ooh, this doesn't quite match. This color is completely different than it looked in the store. And companies realize that this is a problem. So in the global textile complex, right, in the world of creating textiles, companies recognize this problem and they conduct a lot of color matching assessments using multiple light sources. And their goal is to focus on the light sources commonly encountered. So those in stores and homes and work environments and in natural light. So they use multiple light sources to assess the color. The next color theory term that you need to know is called the Bezold effect. And What the Bezold effect is two or more colors that appear to look like a new color, merge into a new color when they're viewed. And this happens when there's a small scale print, what's known as a ditzy print, or in fabrics that were dyed at the yarn level. By dyeing items at the yarn level instead of the fabric level, there is a potential for the color just not to match, right? And one of the other things in the Bezold effect, one of the things that can affect it as well is distance. So, viewing colors up close or far away. And sometimes the individual colors aren't seen, but instead a new color that blends is what we see. So to ensure that the color is consistent, there are several complex processes that occur from the creation of the concept to a finished product in a desired color. And color must be specified and measured, and samples must be created oftentimes before they go into full-scale production. So when specifying color, the process that is used is to provide a color standard. And a color standard is just a large sample of fabric that has precise digital information that represents the standard color. And digital color standards ensure that there's precise color reproduction and reduce time in trying to match the colors. So textile producers and dyers, they don't have to create their own standard. There actually is a company that does that. Pantone is the largest color standard company. They do trend forecasting and color intelligence and sourcing, and they create the standard. So if you use the Pantone standard, you are ensured to get an accurate color across all of your garments. Part of what Pantone does that makes them so valuable is they provide a color measurement, and a color measurement just assigns a numerical value to assess color, and it facilitates the color matching. And color measurement can be done with a trained human eye or with instruments, but Pantone is the leader in creating color measurements. By using the color measurement, the color standard, is the color standard information is converted into a dye recipe based on a reference library, again, usually created by Pantone, and that's developed by a dye house to dye the fabric. And what they then do is they do a lab dip, which is just a sample that the dye house then sends back to the manufacturer. So once the lab dip sample is created, they're assessed digitally to make sure that they, are reaching the color standard using the color measurement, and then they are provided to a company for final approval. And then the color matching comes into place. So that's just the lab dip and the color standard that are created within tolerances. So during production, the color can be checked on a regular basis. And then finally, the completion of this color theory process is what's known as shade sourcing. And that's just grouping fabrics together by color. And that just ensures that all fabrics of one color are purchased by the manufacturer with that match. And it just reduces concern that, different layers that are matched, that are sewn together, that they will be matched. Okay, so you should have color theory down. We understand it's a complex phenomenon with a combination of a whole bunch of science and aesthetics. We learned about Metamerism and the Bezold effect and color standards and measurements and Pantone, a little bit of lab dip and color matching and shade theory. So next we're going to move on to learning about color wheel and classifications.